Hi, as promised, it's teardown time of the new Keysight HD3 or HD300 series 14-bit InfiniiVision MegaZoom 5. None of that MegaZoom 4 rubbish. Scope. So, just released. Let's do a teardown of this. Only waited 13 years because the old one there, the old MegaZoom 4, yeah, I did a teardown of that and review 13 years ago in the old garage lab. So, it's been a long wait for the MegaZoom 5, so let's crack into it. My Phillips ain't going to work there. Looks like we've got 4 posi dry screws there, and it should lift straight off. Metal threaded inserts, of course. Oh, and by the way, there was one mistake in my first impressions review. Well, it wasn't my fault. It was their fault. It's actually got 256 levels of intensity graded display as opposed to 64 on the MegaZoom 4 ASIC. But the datasheet had 16, so that's what I sent in the first impressions review. So anyway, I don't know. There's no cow sticker on this. Oh, bloody nuts. No, I was about to complain that there's not enough room to get those out, but no, they're on the metalwork inside, so no, that's not what's stopping it. Probably some plastic clips somewhere. Yeah, what's this sneaky bugger? Oh, yeah, it's just falling apart now. Here we go. And there we go. Geez, that's really easy. I'm liking that. By the way, I'm shooting this teardown in 4K, and as always, there will be high-res photos available on the EEVblog.com website. So yeah, we've got a big die-cast frame over there. Looks like we've got a right-angle board, but that's only for the back. So all the processory goodness is on the front. Got our big-ass fan there, which is very low noise, by the way. You hardly realise it's on. And 2 big, thick, oh, they're nice. Ooh, they're nice flexi silicone cables there, so that's one big 12-volt jobby, so that's nice. Power supply shield in here, which could just, I was going to say that just lifts off. Liking that. Haven't seen that before. That's some teardown innovation. And they had to go ruin that with one screw. One screw. Oh, come on. All right, so there's our power supply. Ooh, that's a neat little jobby, isn't it? Liking that. Nice earth connection down there. It's actually soldered right down onto the filter down there. Nothing wrong with that. Nice. And, look at that. A little current clamp there around the mains cable. That's how they're tapping off the 50 hertz, 60 for you Yanks, mains triggering. So there you go. And they've put a cable tie on that, so that's all right. Oh, look, little plastic surround around that. This is all very interesting. I'll tell you what, if Keysight aren't careful, they might win an award for sexiest oscilloscope power supply. I'm really liking this. TDK lambda transformer in there. I'm really liking the look of that. Look at that beautiful output choke there. Nice big crimp terminals there for the 12-volt output. They got one trimmer pot there. Little daughter board there that buggers off. Is that doing some extra regulation there? Perhaps a couple of extra rails or something? I was going to say that looks like a big current shunt, but it's no, it's too high in value for that. But that's just looking gorgeous, isn't it? And everyone wants to know what brand main AC filter cap they're using. Oh, it's a Shanghai. Oh, come on, you could have given us a Japanese cap. Anyway, it looks like has TDK Lambda actually designed this little beastie, because it's very, very nice. Anyway, apart from the main input filter cap, everyone's doing it these days. It's all the rage. Anyway, your Y-class caps are there. Got nicely heat-shrunk inline fuse there. And yeah, it's got its own little plastic bottomed enclosure. I wonder why they went for that. Very interesting. And I did try and lever this off, but I just succeeded in chipping it there, so I'm not sure. There's a little pot in underneath or something. Not sure why that silver tape is there. That's interesting. Is that shielding tape? I don't know why you'd need it. Oh, yeah, it could be sealing up a gap, and I just broke it. Oh, no. Interestingly, there's a couple of spare cutouts here. There's a square jobby there, and another BNC there. I wonder what that BNC was for. Or it's for an upcoming model, perhaps. Yeah, I reckon that's a warranty void sticker. So, yeah, bugger that. Oh, that's kind of fun. That's more fun than your usual warranty void sticker. Oh, bonus fun here on the EEVblog. Look at that. And I even get a screw, do I? Yes. Oh, bonus extra. All right, I got the nuts off the BNCs. One of them's loosey-goosey because it's not mounted on the PCB. And this is interesting because all this metalwork is going to stay here. And just this top section, along with all this, should lift off. Unless I've forgotten a screw, which is very likely. Yes, you idiot. Of course you know I always forget a screw. Yep. What sneaky buggers are left? Ah, the clamp. Well, that's annoying, that clamp. Might have to surgically remove that connect. There we go, got it. And I can access these ones at the top. Got to watch yourself you don't cut yourself on the metalwork. Oops, I think I broke that connector. I was trying to get that out and I gripped the wrong point with the pliers and nope, I heard a crack, snap, crackle, pop. Oh. Anyway, dumbass Dave has it open. It's a YS Tech YW120250012BS. Made in China. But feast your eyes on this glorious thing. Oh, I love the PCI right angle interface board here with your digital inputs and everything else, but they had to have that connector. Different. Yeah, that's the WaveGen output. So is that optional? I thought the WaveGen was standard. Maybe it's optional. But there you go. Got the processor on a separate board over here. That's interesting. That's not the MegaZoom baby. These would be the ADCs, and that'd be your MegaZoom 5 ASIC under there. 3 main bad boys here. And let me go inspect that connector with my microscope. Because I've come a gutser, I think. Let me see if I've come a gutser here. I don't think so. I think the solder joints are intact. Yeah, see, those solder joints look intact. It was the top side that seemed to have lifted off. They look pretty good, don't they? Yeah, there's no lift in there at all. Focus, you bastard. The plastic actually lifts up here. I have to get my scissor lift to raise the Tagano up to see under there. Oh, no, there it is. There it is, that ground connector. That's what's come off. The ground jobby over there. The massive ground pad. Wow. Okay, well, I can touch that up. Wow, of all things. The little signal ones look okay, although I just might touch them all up as a matter of course anyway. But they've got like pins dual side in the middle there. That's kind of one of those oddball jobbies. I'll touch it up. I don't think I've damaged anything though, really. And nice attention to detail. There's actually 2 outer alignment slots here. So I've taken off the screws on there. So this board, and it comes out of there like that, lifts out, and there's just, yeah, beautiful, molded into the chassis there. Bobby Dazzler. Ooh. There's the backside. Here's a beautiful bit of attention to assembly detail. Look at this, right? Got some Kapton tape here. Kapton tape is actually designed to get that lever handle up like that, so that then we should just be able to pull that out. Oh, beautiful. Mwah. Right, so I've taken off the output board, and I think I've got all the screws in here, but there's some captive screws on the rear side, so I'm with screws in them, so I assume that's the front end. How does this come up? I have to be gentle. Aha! That's what the screws on the front of the BNCs are for. Yeah, let me get those off. That'll ruin your day. Something very therapeutic about this. Now, it might look like I'm being a bit medieval here, but I'm going to show you that I'm a professional and I know what I'm doing with the big screwdrivers, and I can see down in here, and yep, there's an entirely separate front end board. Yeah, there you go. It pops out, just as I suspected, because I know what the designers are thinking. There you have it. There is our front end board. damn, there's a lot of passives on the back of that. And unfortunately, with the super low noise front end, I was afraid of this. They've soldered the can down. Oh, wouldn't you believe it? Can top and bottom. So if I want to get a look at their new super low noise front end, then I'm going to have to desolder this turd. Oh, no. But check it out, they've got the RFI sponge there. They've manufactured a custom BNC block here, which is like really fascinating. I've never seen like a custom, maybe some old school LaCroix or something. But yeah, they're those mounting screws that go onto the front there. But yeah, they've custom engineered the BNC block. Oh my goodness. And then you can see down in there, board-to-board interconnects. That'd be analog out of there because your ADC's not on here. So that'd be analog going over the connector there. You don't see that too often these days, let me tell you. And look at all the decoupling. So these have been the two big new custom ADCs here. So these are your 14-bit ADC jobbies. And that up there is your MegaZoom 5 ASIC. So all your decoupling, they've gone to town on that. And they've got a couple of these on the top side. These tapes here. This would be thermal tape. And just added a little bit of heatsink, and they've even put a silkscreen overlay on there. Tape 3 of 3. Look at that. There you go. They've got a matching shield in tape on the bottom side of that same circuit there. I haven't looked, I've taken some photos, haven't looked what's actually on there yet. There's the underside of that one there. What's doing? And there's nothing else there except a little, once again, PCI interface USB board. That's just for those two USB connectors on the front. And what do we have over here? We have a hole on the front panel. Look at that. It's not the regular BNC like that. And if you actually look down on the board down here, you can see that there's an unpopulated footprint, the same as over here, but obviously they're not going to have like another double channel here. This isn't going to be they're not going to have a 6-channel option. So that cutout in the front looks like a larger coax connector. Is there going to be a spectrum analyzer plug-in? Well, I've got the clip off the heatsink for the ADC, and she ain't budging. I think I'm going to phone a friend at Keysight, and I'm going to say, hey, what's doing? Can I just apply more force to this? Will it come off, or am I going to break a mega expensive 14-bit ADC? This will delay the video a bit. Let's take a look at the PCB. Now, I thought this would be easy. Okay, you got your applications processor over here. These are obviously the new 14-bit ADCs, right? I mean, look, you've got your differential pairs going in here like this. So there's obviously two ADCs because the sample rate doesn't split. So there's obviously two 14-bit converters inside each one of these new ADCs here, right? No worries. And obviously, this is the new MegaZoom 4 ASIC, right? There's something weird going on here. Look at this. Up the top here, FPGA done. What FPGA? I don't see an FPGA. So this must be an FPGA, not the MegaZoom 5 ASIC. But that's not all. Look at this. Look at the bottom side here. This is what I thought was the, well, it is obviously the ADC because the differential pair signals are going in. Look at these differential traces going off here. These are connected directly to the memory chips and not to the, what I thought was the MegaZoom 5 ASIC up here. So the only conclusion I can come to is that this is both the ADC and the MegaZoom 5 ASIC. Oh, is it some sort of like hybrid chip? Because I can't imagine them doing like this really extreme high-end, high-performance 14-bit ADC, this new whiz-bang ADC, along with the MegaZoom 5 ASIC in the same process, like as in silicon process. Maybe they can. I don't know. I'm not an expert in that area, but maybe it's a hybrid chip, and this is like an all-in-one oscilloscope thing. The MegaZoom 5 is like, has the 14-bit ADC dual channel, 14-bit ADC, and the MegaZoom 5 ASIC in it. But unfortunately, I can't get the heat sinks off yet, and I don't want to apply extra force or try and heat them up. I have asked Keysight, and they haven't gotten back to me yet, so because they're stuck. These things ain't budging at all. You can see the memory chips here, and they're tied into the ADC. But wait, there's more. Check this out. Once I get the module off here, channels 3 and 4 here, this extra connector over here, which I speculate is like a spectrum analyzer module, it's the only thing I can think of, it's not extra analog channels. You'll notice that there's a signal going out here, and it's surrounded by the ground traces on either side, and it goes into the ADC. And there's 2 of them here. So it's either one differential pair, but then why would you separate it with the grounds? That's a bit unusual. So I can only presume that it's maybe 2 single-ended channels coming out of this optional, what I presume is a spectrum analyzer board. I and Q signals, maybe? That'd be interesting. Yeah, so this ADC is not just 2-channel 14-bit. It must contain at least an extra 1 input and maybe an extra 2 inputs here, because we know it's not multiplex because the sample rate doesn't halve. Maybe it does. Maybe it's got like an input mux for these extra channels here which aren't, and feeding into the 2 channels or whatever. So maybe it is still a 2-channel ADC, but still, yeah, it's got extra inputs here, and they just don't use them. They don't connect those on the other ADC on the other side. So if this is true, that this is a combined MegaZoom ASIC and 14-bit ADC, dual 14-bit ADC, at least dual 14-bit ADC into the one chip. Basically an oscilloscope in one chip. You know, you got to add the processor on, and maybe you need that small FPGA above, or you combine it into, say, a Xilinx Zinc processor, which they don't have on this one. But what I'm thinking about is that if this is the case, then you could have one of these chips, one, plus a Xilinx Zinc processor, and that's it for a lower end scope. That's 14-bit MegaZoom 5 and all the bells and whistles, but then they'd multiplex. They would multiplex, because if it does actually have 2 ADCs in it, but actually 4 inputs that are multiplex, because we know there's extra inputs here, then maybe, my speculation is, that's ripe for a low-end version eventually. Don't expect it this year or next year maybe, but you know, in a few years time, maybe lower end version of this scope where they save costs, because this is not a cheap ASIC of course, but given that it's an ASIC, once you've got that NRE cost down, that non-recurring engineering cost, once you've paid for that, once you've absorbed that, then it, relatively speaking, the ASIC becomes cheap or cheaper than what you'd pay with if you're buying the ADC from Texas Instruments or Analog Devices or whatever, and you're buying the FPGA from, you know, Xilinx or whoever. So anyway, interesting, huh? And as for the processor, there it is. It's a Freescale Jobby MIMX blah 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 blah, and there's no heatsink on that, so obviously it's not doing that much. But you'll notice that there are actually 2 extra standoffs here integrated into the board that would be for a heatsink. They wouldn't be there for anything else, but I guess they deem they don't need the heatsink because it's not doing much, because all the heavy duty work is being done in the MegaZoom ASIC and or the FPGA above. That's why they have the heat sinks. And they're not particularly big heat sinks anyway, but anyway, they do have the fins in the correct direction because the air blows across here like this or the other way. Now, apart from that, there's nothing else much interesting in here. Here's the function gen output down here. You can see the connector down here. Here's the 50 ohm output impedance down there for that, and some relays and stuff. And there's probably some drivers down here. I won't go into particular detail, but I don't think you'll find a DAC here because I believe that's inside the MegaZoom 5 ASIC, which now I presume is this here. And by the way, those wondering what are all these little copper pads here, and they also have those on the analog board, which we'll take a look at in a minute. That's copper thieving, it's called. So they put that on there so that when you electroplate the board at the manufacturing, bare board manufacturing stage, you get a more even coating spread across the board for your plating. So the nickel gold immersion plating or whatever it is you just get a more balanced coverage if you actually have a similar amount of copper. So it's copper balancing, copper thieving, it's called. And check out this. Obviously, price point wasn't a problem here. These linear technology power modules here, very schmick. Mwah, beautiful, but they're not cheap. But this scope ain't cheap. So the designers obviously just went, oh, bugger it, I'm not going to design my own DC to DC converter, bugger that, not going to roll my own, I've got too many other issues to deal with, I'll just use this linear technology jobby, thank you very much. So spec in 2 of those there, no worries. Oh, and they've got another one over here too, cool. And if you look up the part number for these Micron memory chips, and yes, they do have 1 memory chip per channel, so you don't have to share. And if you look that up, that's a Micron 512 meg by 32. So there you go. That's how they get their 100 meg points, 100 meg samples per channel. So obviously that has more than it needs. So that's excess there. They might be doing some, intensity graded stuff with the extra memory or something like that. Oh, actually, when I look closer at these ADC inputs, you can see that they do actually run ground either side of there. So that is obviously a differential pair, coming from the same channel. So they do actually run grounds in between those. So the one coming from this spare connector over here, that could be 1 differential channel, but I still wouldn't rule out 2 single-ended. And offhand, I can't identify the board-to-board interconnect here, but obviously they're using that to get the 1 gig bandwidth analog signal across, and no problem. Board-to-board, really high frequency, high quality board-to-board interconnects are a dime a dozen these days. Because you've got to remember, the signal that's going from here, and it'd be going underneath here, it'd be going on the inner layers, and that is an analog signal, but you've got to remember, that is not a high impedance source signal, that's a low impedance being driven from a low impedance differential amplifier that's on the analog input board and then going over. So yeah, like interference and the rest of it's not a problem. It's a low impedance source. It's hard to interfere when your source is low impedance. Well, I just heard back from Keysight and I was absolutely correct because it was the obvious assumption, really. Sure enough, these are a combined MegaZoom 4 and the new 14-bit ASIC. It's a scope on a chip, as they call it. Why they're not massively advertising that, I don't know. But yeah, apparently they're very proud of the effort they put into this. It is literally a scope on a chip. So yeah, I still don't know if it's a hybrid or not, or what the silicon process is or whatever. If I can find any more details, I might update in the comments down below. But yeah, that's all you need in theory, and a little processory FPGA thing to go ahead with it. I still don't know what this FPGA does, but just basically anything that the MegaZoom 4 can't handle. And here's the analog front end, cans desoldered here, rip to a couple of pads here. So yeah, oopsie. They weren't tight, like they're not onto a solid ground plane, so the heat just lifted them up. So swear my iron was only on there for like a second before like the solder melted, but still the pads came up. So what we have here is a brand new ASIC. So yeah, this front end is really nice. Now, there's a couple of interesting things here. Yes, I did take off one of these shielding cans here. This would be a mu metal can, I believe. It's the exact same relay underneath here. So I assume that they're all exactly the same. Panasonic jobbies, beauty, made in Japan. All the best stuff's made in Japan. It is genuinely a single chip solution, apart from a little 272 op amp over here. So nothing special. 272 dual op amp, upside down, all the electrons are going to fall out. But apart from that, on the bottom, we've got some solid state relay here and solid state relay here. Apart from that, it is literally a single chip solution. Nice. Like, I don't even see any extra transistors on the top here at all. There's 4 on the bottom here, sure, but they could just be diode protection or something like that. But yeah, no external transistors on it. That'd be a localized voltage regulator there by the looks of it, when you got a cap on the input and output like that. Yep, it's got to be. Yeah, of course, you'd expect a localized regulator for the analog front end. There is a couple of unpopulated voltage regulators here, so I'm not sure what's going on there. But anyway, here's the board-to-board interconnect, and obviously this is the differential pair that's coming out of there like that. Wiggle, 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 yeah, to trace length match that. So this is the 1 gig bandwidth output going straight into here. So it looks like probably the top 2 pins there are your differential signal, and on the other side, the opposite end of the connector, is the 2 pins coming from the signal from the other channel. Okay, so what we've got is our signal coming in here like this, and then this would be going into the relay under here. So that would be putting the signal through to there, and then that would be a signal down to ground there, because that's routing all the way around, all the way right over, straight back to the input connector over here. But it is interesting that it goes all the way back to the connector over here, but yeah, okay, fine. It's like that was the lowest noise point in the system, I guess, star pointing it back to over there. Yeah, fair enough. Okay, so then we've got our output over here, and this comes into another relay which has two terminals. Please excuse the crudity of the model, didn't have time to build it to scale or to paint it. And this is obviously our 50 ohm path here, so this actually goes into another relay. Okay, so what we've got here is 3 separate paths into our front-end amplifier here, our programmable gain amp, and what one is, so this is the 50 ohm path, obviously this is the DC path here, and here's the two 50 ohm resistors, so well, 50 ohm total, these would be 100 ohms a pop, then just another series resistor there, and then some just protection and filtering and whatnot, and that goes into there. So that's the direct AC path, and then this relay here is just the AC coupling relay. So yeah, it's just AC couple there, that's probably that capacitor there, and that just goes in there like that. And this other path here, this is the 1 megohm path, but it gets interesting. It looks like there might actually be a tap off here, and is that the AC input coupling for the 1 megohm? I'm not entirely sure, because usually they use the solid state relay to do the AC coupling capacitor bypass. So I'm not going to completely reverse engineer this thing and get a schematic out of it. So yeah, this will just be some hand waving stuff. But this is really interesting. They've actually got 2 separate 1 megohm input terminators here. So these are 499K each. Okay, so they're in series like that. So there's 2 of them. Why is there 2 of them? It's because they're doing different residual compensation on the input based on which attenuation setting they're actually choosing, because this thing's going to have 2 main attenuation settings. I think it's when you switch from 100 to 200 millivolts, you can actually hear the relay click in there, and that's the 2 major attenuation ranges, and then the rest of it, of course, is done, or they get all the other ranges based on their programmable gain amplifier inside this thing, which would also have bandwidth limited filtering as well inside all that. So yeah, they've got 2 separate paths, so that's interesting. 2 separate 1 megohm input resistors. I'm not sure if I've seen that before. That might be kind of newish. Yeah, they just maybe had to tweak a bit of compensation tweaking for the different ranges, for the 2 different attenuation ranges. So yeah, that's it. Usually it's just, you know, you share the 1 megohm resistor. You know, you have your 1 megohm resistor here, and you go down to ground here, and Bob's your uncle, and then you choose your different attenuation paths. But they decided to have 2 different input 1 meg resistors, so that's pretty groovy. And then for some reason, there's what looks like a high-ish voltage, because there's 4 resistors in large resistors in series. The only reason you do that is high voltage, like series path here. So I'm not sure what's doing there. Yeah, I'd have to do a complete reverse engineering to figure out what's happening. But anyway, basically we've got the 1 megohm path with its different attenuation settings and its AC coupling, and then you've got AC and DC coupling paths. So the 1 megohm path is only 500 megahertz bandwidth down here. But if you want the 1 gig, full 1 gig bandwidth, you've got to use either of your 50 ohm paths. Anyway, that's very interesting, totally custom ASIC, and the new MegaZoom 5, they said that they'll send me a picture. They're still not sure how to get these heat sinks off, so I'm not going to go and heat it up or apply physical force to try and get it off. If I get a photo in time for this edit, I'll include it for the MegaZoom 5. And sorry, don't know what the FPGA in here is, but it's an FPGA. So it's just doing, you know, miscellaneous stuff that the MegaZoom 5 can't handle. So it wouldn't be particularly grunty, I don't think. So there you have it. I hope you enjoyed teardown of the new Keysight HD3. It's very interesting, and I'm really annoyed that I couldn't actually see the MegaZoom 5, and I don't want to damage it. I'm a wuss, aren't I? Heat it up, Dave. Get a big pair of pliers on there and crank that sucker. Yeah, right. Okay, on my real expensive HD3 scope. No thanks. Anyway, they've got a real interesting platform here, and this scope on a chip is very impressive. Still, they haven't sent me any sort of block diagram or anything like that, but we know it's got all the goodness of the MegaZoom 4 plus some extra goodness in there as well. So yeah, it's pretty awesome. Scope on a chip. So maybe in a couple of years, expect that to see that flow down into lower models. But yeah, pretty impressive, huh? Anyway, thoughts and comments down below. Links to the high-res photos over on EEVblog.com down below. Don't forget to check out EEVblog.store because that's what keeps me in business. Catch you next time.